Hi friends, welcome to my YouTube channel. This is first part of lecture number 28 and here in this lecture we are going to study one phase full wave semi-controlled rectifier with RL or RLE load, and it has freewheeling diode connected in parallel to the load. We will assume that load is highly inductive. So when load is highly inductive, we can consider output current nearly constant. See this rectifier circuit. Here there are two rectifier and two diodes. Freewheeling diode is connected parallel to the load. Vs is the source voltage which is applied between points A and B. Vs is equals to VAB and that is equals to Vm sin omega t. Now we will see the operation of this circuit in three angular modes. First we will see the operation from alpha to pi, then from pi to pi plus alpha, then from pi plus alpha to 2 pi. First see the operation from alpha to pi. Here freewheeling diode is reverse biased due to polarity of voltage VAB. At omega t is equals to alpha, VAB is positive. So T1 and D1 are forward biased. When T1 is triggered at omega t is equals to alpha, then T1 gets short circuited while D1 is already on. So T1 D1 act as shorted while reverse biased D2 and T2 act as open circuit. Circuit will look like this, in which current will flow through Vs, T1, load and D1. Apply KVL in this loop. We get V0 is equals to VAB is equals to Vm sin omega t, and current through T1 D1 is also I0. So we can write IT1 is equals to ID1 and that is equals to I0, and due to conduction Vt1 is equals to Vd1 that is equals to 0. It means drop across T1 and D1 will be equals to 0, while D2 and T2 both are open circuit. So we can write IT2 is equals to ID2 and that is equals to 0. Now apply KVL in the loop containing Vs, T1 and T2. We get Vt2 is equals to minus Vs and that is equals to VBA. Similarly, apply KVL in the loop containing Vs, D1 and D2. We get Vd2 is equals to minus Vs. So source current Is is equals to I0 in this circuit. We can clearly see from this circuit. See waveform. V0 is equals to VAB, I0 is equals to constant, Is is equals to I0, IT1 is equals to I0 and Vt1 is equals to 0. And we know that freewheeling diode is reverse biased during this time period alpha to pi. That's why current through freewheeling diode is equals to 0. Now see the operation from pi to pi plus alpha. Polarity of source voltage reverses after omega t is equals to pi. So freewheeling diode get forward bias and it will start conducting. Okay, during forward bias it will act as short circuit and start conducting. Now whole current will shifted to loop containing freewheeling diode and load. The current will start freewheeling in this loop which has freewheeling diode and load. So no current will flow through T1, D1, D2 and T2. So we can write IT1, ID1 and ID2 and IT2 all equals to 0. Also Vd1 is equals to Vd2 is equals to Vt1 is equals to Vt2 and that is equals to 0. Only we get freewheeling diode current that is equals to I0. Here see the waveform. You will see V0 will be 0 due to sorted path in parallel. Okay, why it is 0? Because it has this short circuited freewheeling diode in parallel. So in the waveform from pi to alpha plus pi, V0, Is, IT1, Vt1 all are 0. Only freewheeling diode current I0 is present. Okay. Now from pi plus alpha to 2 pi, see the circuit operation. Thyristor T2 is triggered at omega t is equals to pi plus alpha and D2 is already forward biased. So both start conducting and act as short circuit. So Vt2 is equals to Vd2 and that is equals to 0. Also current now will start flowing through T2 and D2. So IT2 is equals to ID2 and that is equals to I0, while T1 and D1 are reverse biased. So they will act as open circuit. So IT1 is equals to ID1 is equals to 0 and circuit will look like this. Here current will flow in the loop Vs, T2, load and D2. Apply KVL in this loop. We get V naught is equals to minus Vs, and that is equals to VBA. Also here Is is equals to minus I naught. Now apply KVL in the loop having Vs, T1 and T2. On applying KVL we get Vt1 is equals to Vs, and again apply KVL in the loop having Vs, D1 and D2. We get Vd1 is equals to Vs. Now see the waveform. Here from pi plus alpha to 2 pi, V0 is equals to VBA. I0 is constant. Is is equals to minus I0, It1 is equals to 0, and Vt1 is equals to Vs, and that is equals to VBA, means VAB. So VAB will appear across this thyristor T1, and here in this template, due to reverse bias, freewheeling diode current is equals to 0. So this is all about this lecture. I hope you all understand the concept. Now if you want the notes of this lecture, then you can write in comment box. Thank you. Jai Shri Ram.